Hello, YouTube. This is Jay Coder back with another stream. And in this stream, we're going over how to solve the coding challenge Word Break 2 on LeetCode. And I'll have a link to that problem too in case you all want to check it out. And so subscribe to the channel if you like this kind of thing and like the video, comment, and let's get started. All right, so what I have for you guys today is here the word break 2. And so it says, given a string S and a dictionary of strings word dict, adds spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Note that the same word in the dictionary may be reused multiple times in the segmentation. And then here's an example. The input S equals these words here. And so the S is this, and the word dict is this. So based on this, we can construct these words, and then the output is this: cats and dog, cat and dog. So, okay. And then, so example 2, you have the pineapple and an apple, and then um, these can be constructed from that. And then the output is this, where it's the pineapples like that, and or the output is like that. Note that you are allowed to reuse a dictionary word. So yeah, and the constraints are: one is less than or equal to the length, and less than or equal to, which is less than or equal to 20. So the length can't be more than 20. The S length, the string length, the word dict cannot be more than 1000 or less than 1. And the each element cannot be more than 10 characters. So S and word dict sub I consist of only lowercase English letters. All the strings of word dict are unique. Input is generated in a way that the length of the answer doesn't exceed 10 to the fifth. Okay. And just a recap, given a string S and a dictionary of strings, word dict adds spaces and S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in an order. In any order. Note that the same word in the dictionary may be reused multiple times in the segmentation. So our job is to add spaces to construct a sentence where each word is a valid dictionary word. And so, all right. So they have here a method called word break, and then it takes in the string and the word dictionary, and then, all right. So what we need to do is we basically need to convert the word dictionary into a set so that we can do a more efficient lookup. So basically, for a set, we can say here constant equals dict equals new set word dict. All right, so we have that. And then we need, and then after that, we're gonna initialize a memorization cache to store solutions for sub problems. So it's going to be a map, and this is going to be our cache to store sub problems. And so I'm gonna call it memo. All right. And then the next thing is to define the backtracking function that returns all the sentences formed by index start. So basically, I'm going to define a function here, and it's going to be the backtracking function. And I'm going to go ahead and have a variable with a default value of 0. And then we're going to go ahead and start the body there. And so now I'm going to do the base case. When start reaches the end of string s, I'm going to return an array with an empty string. So basically, the first thing is this. So if start equal the length, the s dot length, and then we are going to return a blank. And then the next thing is we're going to check if we have already solved this sub problem. So if yes, return the stored result. So basically we can say if memo dot has start return memo dot get, and then that would be start. And then the next thing is I'm going to initialize an array to store all possible sentences starting from start. So this is going to be my array here, which is this is going to be Okay. And so now, after that, I'm going to try every possible end index for the current substring. So I'm going to make a for loop to loop through the string. And so the string that we have been given here in the method. And then, so what I'm going to do is I need to construct a for loop. And this for loop is going to for let n equal start plus 1 end is less than or equal to s dot length, and then it's going to be end plus plus, and then we're going to, after that, we'll need to extract the current substring. So in order to so, so in order to extract the current substring, I need to make a variable here, constant word equals s dot substring, then the start and the end. Okay. And then after that, I need to do an if statement that checks if the current substring is a valid word. So basically, we check to see if it's a valid word. So basically, if dict dot has word, and then we will check in here that basically, if it has that word, then I need to recurse to get all the sentences formed by the remaining substring. So in order to do that, I need to declare a variable that, so I'm going to say this is going to be constant, and this is going to be uh, a this is going to be a the sub sentences is going to equal to the recursive back track, and then the recursive backtrack I pass in the end, and then after that I need to concatenate the current word with each of the sentences formed by the remaining substring. So within this, I need to go ahead and do a for loop to concatenate the sub sentences, the sub sentence of sub sentences. So, in order to do that, I will need to do for constant sub sentence, and that's sub sentences sub actually sub sentence of sub sentences. Actually, sub sentences is actually here, so I need to have that here. And then as we loop through, we are going to do concatenation. So basically add a space between, I'm going to add a space between words only if subsentence is not empty. So only if subsentence is not empty, we're going to go ahead and add a space. And so what we're going to do is we are going to, within this for loop, is do a sentences dot push, and then what we're going to push is the word, then concatenated with the sub sentence. So actually, it's going to be, so we're going to check, if it's not zero, if the length is not zero, then we're going to do our concatenation or the adding of the space. And then we're checking if that is greater than zero. Then basically, if it's greater than zero, go ahead and add a space. If not, then we don't add a space. And then after that, we're going to plus that with concatenate the sub sentence. And then after that, after we have concatenated the sub sentence, that's what we need to do in our for loop. And then basically after this outer for loop, we are, let's see, we are going to store the result in a memorization cache before returning it. So basically, in order to do that, after this for loop here, we need to say, so basically here, I'm going to say memo dot set the start and sentences, and so we set the memo cache, and then we're going to return sentences, return sentences. Okay, so we return sentences right there. And then now, after our backtrack function, we need to go ahead and return the calling of our backtrack function. So I'm going to start the backtracking process from the beginning of the string. So we simply return the calling of the backtrack. Then that will call our backtrack method and then do the calculations and return the sentences output. And it's a recursive function that keeps calling itself for the multiple sub sentences until there is no more sub sentences, which the length will be 0. And then we should have the sentence to once we have that, we save it to the memo, and then we continue until it's processed. So, all right. So, let me just have a look at this. So we have the word break function. Then we have the two variables, and then the backtrack function, and so then we have the if statement. Basically, that's just going to return this if the length is equal to 0, basically. And then we have the if statement here. If this, we return memo.getStart. So if we already have solved the sub problem, and then the constants, then we have an array of sentences, and then after the array of sentences, we have the for loop that loops through the string that we're given and processes that with the word equals s.substring, pass in the start and end, and then if the dictionary has a word, then do this backtrack again to get the sub sentences, and then after that, it's a for loop that so then there's the for loop that um, basically loops through and as the space basically to our sentences. And so basically it's checking if the length is greater than 0, then go ahead and add it. Then if not, then don't add anything. So let me see. So basically we have the says that push word sub sentence. Gotta make sure I spell that correctly. And then is greater than 0. And then the question mark. And then we have that. Then the colon. And we have then add nothing there. And then we need to concatenate our sub sentence. So we concatenate our sub sentence, and then all right, then I can probably add a semicolon there, and then after that we are going to add it to our cache memo. So memo dot set start sentences, then return sentences, and then we're going to return our function. All right, so I went through that, and now let me see what happens when I go ahead and run it. All right, boom. It is correct. So we have our input here, and then which is that, our word dictionary, which is that, and then our output, which is that, and then expected is this. So that's great. All right, and then for this one, we have our input is this, and then our word dictionary is that, and then our output is this, and expected this. So, all right. So, yeah, basically, that's the problem that we have done today. And again, here is the solution. Let me go ahead and go over. So, all right, here is the solution. And yeah, if you like this kind of stuff, subscribe to the channel and like the video, comment, and as always, stay coding. And thank you for watching, and see you guys next time. Peace.